Hello there. Today's topic is combinations. Before we actually start the video, what I would like you to do is to try this activity. There are 4 different types of candy available: caramel, suckers, rockets, and gum. Billy Bob wants to put 3 different candies in each bag. How many bags can he make? Take a minute, pause the video, and try to answer this question. As a hint, you may want to make a list, but find out how many different bags of candies he can make. So pause now, try the question, and then come back. Welcome back. Hopefully you got the answer as being 4 different bags of candies. Now some of you might have answered that there were 24 different bags. If you answered 24, then you were probably considering all of these cases. So if you had a caramel, sucker, and rocket, you were thinking that there were 6 different ways to arrange those 3 candies. However, in this case, if you're just putting candies into a bag, you're not actually arranging them. So all of these 6 cases produce the same bag of candy. Same with this 6 and this 6 and this 6. So for each of the 3 groups of candies, if you remove the factor of 6, then that's how you get the 4 bags. Now, you're not way off. If you started off by answering there's 4 candies and you're going to make arrangements with 3, that gives you 24. So if you started that way, what you would have to consider is that for each of these clusters, there were 6 factors, which is 3 factorial ways that the bags could have been the same. And that's where the 4 comes from. So if you had 4 candies and you're arranging 3 of them, well, arranging 3 of them produces the same bag. So that's why you have to divide by the 3 factorial. 3 factorial is 6 because all 6 arrangements of these 3 candies produce the same bag, and that's where the 4 came from. Now, this calculation is actually 4C3. So what we're working on today are using combinations instead of permutations. So with a combination, it's not an arrangement, it's a grouping. So what makes the difference is, in this case, the order doesn't matter, whereas permutations, which we've been working on, the order did matter. So a combination is a set of objects in which the order is not important. So in order to get NCR, what we can do is take our NPR and divide it by R factorial. And if you remember, the formula for NPR was n factorial over n minus r factorial. So that was the formula from a previous lesson. So then you just have to divide that by r factorial. And that becomes the formula for NPR. N still represents the total number of objects, and R still represents the number of objects to choose. And different people write it different ways. You can use the notation NCR. There's also the notation CNR by some calculators. And a little bit more of an old-fashioned way was to write it like this, almost like a fraction but without a fraction bar. But the N on top, the R on the bottom with brackets, and people would pronounce that as N choose R. So if you see any of these formats, it means the same thing. So what I want you to do is to find the button on your calculator, the NCR button, and just try 7C2 and make sure you can get 21. If you need to pause the video to try that, do that, but find the NCR button, make sure you know how to use it, and make sure you can get 21. What's going to make these questions difficult when we start mixing them together is knowing whether or not you use NCR or whether you use NPR. You have to read from the question whether or not you are making an arrangement or whether or not you are making a group. So if you have 10 people, in how many ways can you make a committee of 4? Well, a committee is a group. There's no order to these people in the committee. So there are 10 people, that's N. We want 4 of them, that's R. So this would be just 10C4, which would be 210 committees. Don't forget your units. So that's a very basic knowledge question. We start getting into some harder knowledge questions and some application questions. And you're going to get questions involving and or. So if you remember, any question involving and means you're going to multiply. So there are 12 boys and 14 girls in a math class. How many ways can a Math Olympics team of 3 students be selected if the team consists of 1 girl and 2 boys? So that means multiply. So we have 2 groups, which means we have 2 N's and 2 R's. We have the boys N and the boys R. We have 12 boys and we want 2 of them, so that's R1. And we have 14 girls, which is the N for girls, and we only want 1 girl, so that's the R for girls. So in order to have 1 girl and 2 boys, that means we have 12 boys and we're going to choose 2 of them, and we have 14 girls and we're going to choose 1 of them. So these are the boys and these are the girls. And that works out to 24 teams. So that's a question involving and. There are some questions that involve and as well as or. There are 5 women and 6 men in a group. From this group, a committee of 5 is to be chosen. How many different ways can a committee be formed that contain at least 4 women? Well, you have to be really careful by reading those words at least. A lot of people miss that and they only do an example for 4 women. At least means you can have 4 women and 1 man, or you can have 5 women and no men. So here we have, there is 5 women in total, so that's N1, and 6 men in total, so that's N2. So if we want 4 women, that's R1, and 1 man, that's R2, or the second example, this would be R1 and this would be R2. So in this example, what we have is 4 women. So there's 5 women to choose from. We want to choose 4 of them. And if there's 4 women, that means out of the 6 men, you have to have 1 because you need a committee of 5. So if 4 of them have to be women, then 1 of them has to be a man. So that's one case. Or you have another case where out of 5 women, we want 5 of them, and out of 6 men, you want none of them. And that works out to 31 committees. So watch out for those examples that have ands and ors. Lastly, just want to remind you about these at least 1 questions. If you remember, At least one question means we take the total number of cases and subtract the case you don't want. So in this example, a school has scheduled 5 volleyball games and 4 basketball games. You have a ticket allowing you to attend 3 of the games. How many ways can you go to at least one basketball game? So all of the total cases means you can go to 3 volleyball games, no basketball games. You can go to 2 volleyball games, 1 basketball game. You can go to 1 volleyball and 2 basketball, or you can go to 0 volleyball and 3 basketball. So these are the total cases. The case that we don't want is no basketball games, because we want to go to at least one basketball game.